Hey, so one of the nice things of Figment is that we can use it to train our own datasets, so our own models using our own custom datasets. And one of the tools we like to use for this is called PIX2PIX. And what it does is basically is an algorithm that turns one image into another image, and it learns this transition. So a very typical example is to take a colored image or a black and white image and turn that into a colored image. And or here, for example, you take an image that has a part missing and you try to fill it in, fill in the blanks thing. The way that this is trained is actually to do the opposite transformation. So for example, we already get some images that already have color, and then we remove the color from it and we turn these around. So we let the machine learning model figure out how to move or to add color to a colorless image or to a black and white image. So in order to do that, we need to have two things. We need to have a data set, and we need to pair these images up. So one image and one like source image and one target image. And then also we need a training script, and we'll go through that in a minute. So the dataset that I wanted to use today is from does not exist. This person does not exist. And it's based on a project by Alexandra Fraser, who did this Maureen project, which you can check out on our website. And this person does not exist is images from PIX2PIX. So from NVIDIA's model where it generates images. And there's a lot of them. It's basically infinite. And what I've done, I downloaded 5,000 of these in a zip file, which you can find here on the website. Does not exist.zip. The other way that you can get it is in Figment to use a fetch image node and then hit this URL. So I'll show both approaches. I'll open Figment here. I'll make a new sketch so you can see. So this is a default sketch. We'll double click and create a fetch image node. This by default just fetches the logo from our website. But if here we type the URL, this person does not exist, and we press enter, we actually get one image. And what we can do here is we can say refresh, so reload this image and refresh it like every second. So now every second we actually get a new image. So that's one way to do it, and that's also explained in documentation. The other way to do it is to download these 5,000 images, unzip them. We're going to put these in a project folder. So I'm also immediately going to make a new folder, and let's call this PIX2PIX demo project. And I'm going to put these faces folder inside. And first thing, whenever I'm referencing files, it's a good idea to save the Figment project itself. So I'm going to go to File, Save, and go to Desktop, PIX2PIX demo project, and save it here. So I will have two scripts at the end. One is to prepare the images, and one is to do the actual inference at the end. So I'm going to save this one as prepare. And I'm not going to use fetch image. Instead, what I'm going to do, I have to delete this one, is use the load image folder node. And here I'm going to open faces, and I'm just going to say open, and that's going to load these images. Whoa, these are already prepared for us. So these are actually, this is the part that we're going to do in a minute, but I'll show you. So actually what we really want is only this part of the face. And I'll show how we can do that too. So whenever we do these processes, I'm going to leave this out node here. Basically, we want to have our source image here. And here we have both. So what I'm going to do simply is to use a crop to only take out the left side of the image. So here I'm going to say, okay, so the input image is 1024 by 512. And the crop is going to take out part of the image. By default, it's going to take the center, but I want to take the top left or like center left. It doesn't really matter if you do like center left or bottom left, as long as it's like the left side, because the size is correct. So this just leaves us with the image itself. If you have images in a folder that are not the right size, because they have to be 512 by 512, what you can also do is use a resize node and then attach that to whatever you have as an input and make sure that the output is 512 by 512. That's really important because that's what the model expects. So this resize node now is not very useful because the crop is already in the correct size, so I'm just going to delete it. And as I said before, the trick with PIX2PIX is to have paired images. So we have to know what kind of pairing or what we call segmentation we have to do here. And in our case, we want to detect the faces. So I'm going to use detect face. What that's going to do is it's going to take this input image and then get the face out of it. And there's a bunch of modes that we can set this thing to. So by default, this is the contours of the face, but we can also say tessellation, which is a much more detailed face, and bounding box is just a square around the face itself. That's way too little information for the model, so we can do it, but it's not going to work very well. Instead, we're going to use tessellation, which is this highly detailed face here. We can tweak these numbers, like the line width or how many faces it can track. Now we're just going to leave this at 1 because they're always going to be 1. Cool, and then we need a way to put these images side by side, and for that we use a stack node. So the source image comes in this side and the target image comes here. So this is the pairing that we want to do. On the left side we want to see the source image, and on the right side we want to see the target image. Actually, it's the reverse, because what we are going to do is tell the model, hey, we're just going to give you this side, so basically only this image, and now figure out how to make that from it. And what we're going to do with the machine learning is just iterate over these time and time again until the model knows or understands this transformation. So then we're going to pipe it into the out node. And then, of course, we have to make this move. So we can click this animate button, and that's going to change the frame rate here. We can set this even higher because we want lots of images. So what we're going to do here at the end is have a save image node. And that's going to save our paired images to disk. So here we have to choose on export, so only when we're exporting, that's good. And the folder, we can choose another one. Now, in a minute, we'll use this one, which is fine. But here we'll make a new one like faces out or something. We can make them PNGs. It's a bit slower to upload, but they are higher quality. If you're not really concerned with the quality, you can also use JPEGs at a quality of 0.9, and it's almost indistinguishable, I would say. So I would suggest that. Save, and then you go to File, Render, and now you can say how many frames we have. So we had 5,000 images, and the frame rate is the frame rate we said before, which is 30. So we do render, and that's going to render out these images. As I said before, I already have them, so I'm going to stop here, but you can do this, or you have to do this whenever you have a new data set of images coming in. By the way, another way that you can do it is to use the webcam image, so your own face, and then instead of this, you can do like make a new resize node, as we said before. Then we don't need to crop, but we can resize here. Do this, and then we're detecting our own face. So in this case, as I'm moving, I can detect my own face. Sometimes what I like to add here is a transform node as well, so I can scale up the face a little bit. So I like 0.5, and of course in 2 directions, otherwise it's stretched 0.5, so it's a bit closer to the camera, but make sure that you put this image then in both sides, otherwise the mapping doesn't make sense. And then also you do save image, same process here, but we're gonna work with this data set. So that's Figment for now. Next step is to actually do the training, and as I said before, we need a training script for that. I will put the link here, but this is a training script that we've done recently, and it's this one, train Onyx model local. It's what's called a Jupyter notebook. Oh, this is like an old version. I will put the correct version online, but I can download the older version here. Let's see, so we can view the code here and then download that. So this is all script. As I said, I put the right link in the correct folder. I'll put it on the desktop now so you can see. So we have our data set, we have our training script, and then now we need a way to train this. So if you have a fast computer with an NVIDIA GPU or something, you can train it locally. I'm not going to do this on my Mac here because it's too slow. So instead I will use a service for this, and I'm using RunPod. It's nice because you can rent a computer for a couple of minutes or hours or days, and you just pay the amount for that. So I've made an account already for myself, so I can log in. And here what you will do is add some credits. So I have a bunch of credits here, so you can add some credits. And then I want to make a pod, as it's called, which is like a GPU that you rent in the cloud. And here you can see the choice you have of all the GPUs that you can rent. Some of them are a bit more expensive because they're faster. Some of them are a bit slower. So you can basically choose between these. I will choose this one, which is a nice balance between like speed and price. It's $0.9 an hour, which is nice. I can give it a name, so I can call this PIX2PIX training or something. I want one GPU on demand, and then these I have to leave checked on because I want the Jupyter notebook. So I'm gonna click deploy on demand, and this will start a RunPod, and normally it shouldn't take so long to actually see this thing come online. And then once it's online, we can jump into the Jupyter notebook, and we're going to upload our files here. So we're going to upload this does not exist.zip file, and also this IPython notebook, which I'm going to rename because I don't like the one at the end here. Okay. So you see that it's saying here, okay, it's already running. We have Jupyter Lab here, and then we can also log into another way, but we want this one. So we're going to click this link. That's our custom URL that we get here. And as you can see, we have the workspace here, but it's empty. So we're going to take these two files and upload them. I'm actually going to do it one by one because I can explain this one first. That's the model, and then I can upload the this one here. And you should see a little upload bar here at the bottom, which then does the uploading. While it's doing that, I'm going to go through the script and explain a bit. So this script is basically, or a Jupyter notebook is basically explanation and code inside. So whenever we see a cell like this, we can hit the play button here to run this cell. So for example, if I press run here, I see that I actually get this NVIDIA GeForce RTX that I asked for. And then it goes to the next cell, and now I can run the next cell here. So I can press play again. Or what I'm also going to do is press Shift Enter to have this running here. Here it's actually giving an error. So there's like a module that's not installed, and I'll update the script so make sure that it is installed. But it's good that we see this now. So we can run like extra commands to have things installed here. Oh, and it's complaining about other modules, so we'll add that as well. Basically what I'm doing here is whenever I see, okay, this module does not exist, I just do like install the module. And now it's fine, like these other ones are installed already. I can say, okay, I have a GPU. And then here I have this dataset file. So it's currently uploading. So these are another way that you can do it is just to download a zip file that we have provided for you and then download that here. The main thing is that we want this to have in a dataset folder. So I'm going to come back in a minute and then we'll see the uploaded file and then we can continue from there. So we're going to take this and extract the archive. That's going to make a folder here with all the files. It's also going to create this macOS X folder, which we can ignore for now. And then Faces is going to contain all these 5,000 JPEG files. Sometimes it's a bit slow because if I click it here, it's going to actually try to load this folder, which means that it's going to open or like try to load 5,000 JPEG files. And it's a bit slow, but never mind that. So I'm going to click here back to workspace. I don't have to do this step because it's already unzipped. And then I have some helper functions. So this one is going to make a function called should the directory exist, and this is going to make a directory if it doesn't exist. So here, this is the important part. Here I want to say, okay, where's my dataset folder? In my case, it's called Faces. If you called it Faces_out, you should use the same name here. But I just called it Faces. So I'm going to press Shift Enter here. So you can do the same with Run. This is going to make the dataset. One really important thing here is that it's introducing a bit of random jitter, or it can at least. So that means that it's going to shift slightly the images, which in some cases might be a bit better. In other cases might not. If you want that, you can remove this thing here from the comment and you get that. Otherwise, just leave it there. But then it will be like very precisely fit to the face that you get, like dataset. All of these does not exist faces. They have the mouth and the eyes on the exact same spot. So in my case, applying some random jitter is actually a good idea. Again, Shift Enter. And this thing here, this step here, will actually show one image. And this is really important because you can verify that it's working. So this is the input image. That's what the model sees, and that's what it has to get to. And if we run this cell again, we get from the dataset another input image and another target image. And then we built the model itself. So we create like this unit block. I'm not going to go through the whole thing, but it basically has a generator and a discriminator that fight each other. So as the model gets better at detecting what's a real and not a real face, it's going to get the generator, improve the generator as well to generate better faces. And then, so these are all the like preparing steps, and this is the actual step that does the training. So once we hit Shift Enter here, it's going to start up the model. It says no snapshots found. So the very first time it's going to do this, it will first see if there's an old snapshot. So it's going to save every so often, it's going to save a whole snapshot of the state of the model itself. And this is useful if you want to keep training, or you trained a bit, but then you want to keep training after. You can download the snapshot and restart from there. I'll show that in a minute. So what I created here as well is this output folder, and this is where our model is going to live. So we can open this up. And right now, all it's doing is it has generated this image. So it's going to save that image here, which is the one that we see. So this gives a bit of progress. So you see after a few seconds, basically 30 seconds, we already get like some kind of face. So it detected, it knows that this has to represent some kind of human face, but it doesn't know. So it starts really from scratch. So there's no inherent bias in the model or nothing. It really starts from random values. And so whatever pairing we can do, it's going to train. I will leave this running for a bit, and then we'll come back and download the model. And now, as you can see, we have a bunch of images in our output folder. If you're not in the output folder yet, you can just click here or double click there. And then you also see these generators. And these are the ones we want, because these are the models that go into Figment. So we're going to download the latest one. We now are training epoch 15, so we can download model 14. So right click, press download. And that's going to download a 270 megabyte file, and that contains all the numbers of the training. So all the numbers of the model. The model will actually improve and get better. You see that there's still a lot of artifacts here as we continue, but the model size will be the same. So because all it's doing is it's tweaking the parameters of the model. It's not changing the model's architecture itself. So this generator epoch, I'm going to also put in my PIX2PIX demo project. I'm just going to put the file here. And now we're going to go back to Figment and actually do the training. Oh, I'll also show you how to stop this, because that's important. As long as this is running, we keep getting charged for this. If you want to continue training, you can also download the snapshot, and you can just put it in the same output folder, and the script will pick it up and restart from there. This file is a bit bigger because it's not only containing the generator, but also the discriminator, so the other part of the model. But this is quite important if you want to continue training on this model and not lose your progress. So it's like 650 megabytes. So I've downloaded this as well, and now I can stop this, go to my pods, actually just close this one here, leave, go to my pods here. This is the one that's running, press stop. And then if we just press stop, what happens is that we are going to still get charged because we stopped the model, but it's still like available for us to run. So we need to press stop first. If you want to continue training on a later date, that's fine. You can leave it like this, but I'm also going to terminate it, which means it doesn't incur any costs anymore. So I press terminate here, terminate the pod, and now I don't have anything running anymore on RunPod. So going back to Figment here, this was my prepare script. I'm going to make a new project, and this will start out as the previous one. So I'm gonna create a webcam image. That's my face. I'm gonna resize it. So connect resize here to it. And then the next thing that I'm going to do is I'm going to use this detect faces here. So detect faces. And this will have to be set exactly to the same parameters that we had before. So that means that if we used tessellation before, we should use tessellation here as well. And now we can use that as the input for our model. So we can drag out, and then press Onyx Image Model, and here we can select the model itself. First, so before we start selecting other files, it's a good idea to save Figment here. So I'm gonna, in this PIX2PIX demo project, call this inference, or like running or something. This is the actual running of the model. And here, the only thing I can choose is this generator. Cool. So now I can put these two side by side and we can see what's going on. So as I move my face, I can actually see the thing is strained here. As I said before, these faces are actually a bit closer to the camera, so what I'm also going to do is add a transform node here and make my face a bit bigger, like 1.3 or something. And that's going to give better results because that's more what the model has seen for faces. So there, that's me. And what I can do is actually place this one here and then maybe do a composite node. So this is combining the two outputs here. So it's combining this one, putting that on top, and then just adding the lines with like light on. And then we can see what comes out of here. And it's quite uncanny. Oh, maybe we should actually do it on my face like this. And then put that here and put that here, right? So this is what the model sees. And as you see, it's quite uncanny the way that model sort of turns you into this generic face blob. But this is super nice. And now once you have an out node, you can also go to like here to full screen. And then you can basically make this into like an installation, or just, yeah, maybe just the Onyx model itself, and then do that as like full screen. So whatever you prefer. But this is really a quick way to show you how to train these models. And there's like so much flexibility and things you can try. We'll add some documentation to the website about this. But that's basically the training from scratch approach that we use in Figment.